Alright. So this video is going to introduce you to two things. One is measuring angles in radians, and it's going to introduce you to putting angles on the coordinate plane. So if you've noticed in the calculator, we've always had to switch to degree mode and from radians. We'll talk about what a radian is. So the first thing we're going to do, though, is talk about how we put angles onto the coordinate plane. So let me draw a coordinate plane. Draw my y-axis and my x-axis. Oh, and my x. Why won't it draw an x-axis? Here we go. Alrighty then. So let me just draw it freehand. I was going to try to use a ruler, but it's not going to let me. So there's my x-axis. I'm going to put an angle on there. Here's one side of the angle. And here's another side of the angle. And remember, an angle is just two rays. So we're going to call this angle theta. All right, this right here is called the initial side. Okay, it's where the angle starts. All right, and we always start on the x-axis at 0 degrees. All right, and then this is where I finish. So that's called my terminal side. Okay. As we go around this, remember this will be 90 degrees. All right, so you see that right angle there. Whoops, deleted the wrong thing. Here we go. Let's put that back. Okay. And when I travel another 90 degrees, that's going to be 180. If I travel another 90 degrees, it's going to be 270 degrees. And then finally, 360. All right. If we move in this direction, we're going to be a positive angle. If we move in this direction, we're going to be a negative angle. And let's draw that positive a little bit better. Let's draw it from here, like this. Okay. All right. So let's do some examples. We'll draw some coordinate planes. First, we're going to graph a negative 45 degree angle. We're going to graph a 225 degree angle. And we're going to approximate this. And we're going to draw a 500 degree angle. So here's my coordinate planes. All right, and it's not going to be precise or perfect, but we're going to we'll see. It'll be pretty close. So 45 degrees is half of 90. So I'm going to go halfway, but in a negative direction. So I always start here, and then halfway in a negative direction. So that's a 45 degree angle, or a negative 45 degree angle. For a 225 degree angle, I'm at least going to go to 180, and then I'm going to go another 45 degrees, because 45 plus 180 is 225. So that's this angle. Okay, so I just hit pause to let someone in the room. I'm not sure where I left off. So can I start this problem from the beginning? So 225 degrees, I go 180 degrees. So I went 180, and then I go another 45, because 180 plus 45 is 225. All right. All right, 500 degrees. So I'm going to go 360 degrees. All right, so I'm going to go 360. So I'm going to go 360. And then, let's see, 360 minus, or 500 minus 360 is 140. So I'm going to go 90 plus another 50 degrees. So about to there. All right, so that's a 500 degree angle. So I went 360 and then another 140. All right, so that's how angles work. And that looks really nasty looking. It should be prettier than that. You know, I'm going to erase that. I'm going to draw that better. So I went 360 and then another 140. That looks better. All right, so that's how we put angles into of the coordinate plane. We start with the initial side, which is on the positive x-axis, to the terminal side. We just travel that many degrees. So negative, we move down, and then if we go more than 360, we just keep going until we hit that angle. All right, the next thing we're going to talk about is radians. All right, so we're going to talk about radians now. So what is it, a radian? A radian is another way to measure how big an angle is. So we can talk about degrees, how many degrees we travel. We also can talk about how many radians we travel. And again, we're still talking about a coordinate plane. All right, so if you think about it, let's say you have a circle on this coordinate plane. All right, so here's the circle. And I'm going to draw that better. All right, so here's a circle on the coordinate plane, not much better. All right, first of all, if I start here, that's still going to be 0. And I'm going to have some angle on here, okay? All right, some angle in here. But let's say I travel all the way around the circle. Let's say I do that. So it's 360 degrees, but what is that in terms of radians? So we use pi when we talk about radians. And if you remember, circumference equals 2 pi r. So sometimes some radius. So if we travel around a whole circle, let's say our radius is 1. All right, let's call this a radius of 1. So my radius is here, but let's say it's 1. That means we traveled 2 pi. So when we travel 360 degrees, we travel 2 pi. All right? So 2 pi and 360 degrees are the same thing. So if we travel halfway, half of 2 pi is pi. So 180 and pi are the same thing. And if we do 90 degrees, that's half of 180. So half of pi. So radians, again, we're talking about in terms of pi. And we say, all right, every circle is 2 pi. All right, every half circle is pi, or semicircle, if you will. And then if we travel halfway between pi and 2 pi, that's 1.5 pi's, or we're going to write that as 3 halves pi. So the first thing we need to talk about is how to go from degrees to radians, and radians to degrees. How do we go back and forth from that? So if we think about this, we know 1 pi equals 180. But let's say we want to know, I don't know, how many pi 240 degrees are. We could set up a proportion. All right, you can do degrees over pi. So 180 degrees equals 1 pi. So how many degrees is 200, or so how many radians is 240 degrees? So we would cross multiply, would say, all right, 240 times pi equals 180 times x, and we divide by 180. So x would be the degree times pi divided by 180. So if we want to go from degrees to radians, we're going to multiply by pi over 180. And vice versa, if we want to go from radians to degrees, I'm going to put this here, we're going to do the inverse, which is multiply by the reciprocal. So multiply by 180 over pi. All right, so we're going to do some examples of that. We're going to go from radians to degrees, degrees to radians. All right, so let's do some examples. We're going to do 210 degrees, and we're going to put that in radians. So that's example 1. Example 2, we're going to take 125 degrees and put that to radians. In example 3, we're going to go, for example 3, we're going to do 7 pi fourths and change that to degrees. All right, so example 1, I want to change this to radians. So I'm going to multiply by pi times 180. All right, so 210 pi over 180, and that can reduce, let's see, I think they're both divisible by 30, so 210 divided by 30 is 7, and 180 divided by 30 is 6. And you also could put it in the calculator, 210 divided by 180, and then reduce that fraction. Okay, so 210 divided by 180. Leave the pi out and just put it in your answer. All right, so now we're going to do the same thing for 125. So 125 times pi over 180 equals 125 pi over 180. I think those are both divisible by 5. So let's see. 125 divided by 5 is 25. And 180 divided by 5 is 36. I don't think anything else goes into either one of those. No. But again, I could do 125 divided by 180 in the calculator, math enter, and it'll reduce the fraction. So now I'm going to do a problem where I'm going to change radians to degrees. So now I need to multiply by 180 over pi. So my pi's will cancel out. Tink, tink. I'm going to do 7 times 180 divided by 4. All right, and 7 times 180 is 1,260 divided by 4, and I get 315 degrees. All right, so that's how you go from radians to degrees to radians. All right, so pi over 180 to change to radians, 180 over pi to change to degrees. All right, this slide might be the most important slide of this whole presentation. This is something that I would memorize to make trig better. Not better, easier. Trig's are already great. I will tell you that I still have this memorized from high school because it was that important. So when I went to pre-calculus and calculus, these things were still important. So I would start having this memorized. So we're going to do the most commonly used degree measurements and radian measurements in trigonometry. And we use these a lot. They actually come from, if you remember special right triangles from geometry, we talked about a 45-45-90 and a 30-60-90. Those are still the most common degrees we're going to use. All right, so let's look at this circle. All right, and we're still going to, I'm going to put the degrees on the inside and radians on the outside. All right, so we still have 0 degrees, 0 radians. Okay, so 0 degrees equals 0 radians. So let's put that here. 0 degrees, 0 radians, which is also 360 degrees, and if we just talked about, which is 2 pi. So 360 degrees is 2 pi. All right, now let's talk about some common ones. We're going to talk about 30 degrees, which is about 1/3 of the way in, 45 degrees, which is a halfway in, and then 60 degrees, which is 2/3 of the way in. All right, so 30 degrees, 45 degrees, and 60 degrees. So let's see, 30 degrees, 45 degrees, 60 degrees. Let's talk about what those are in radians. All right, so 30 degrees, when we're dividing by 180. 30 over 180 would be 1/6. So pi 6. .45 degrees would be 45 over 180, which reduces to 1/4. And again, it's half of a half because it's halfway to 90. So it's pi 4ths. And then 60 degrees would be 60 over 180, which is 1/3. So pi 3rds. So now we're going to talk about, let's see, we'll have 90 degrees. And let's go back to the 180 degrees and the other one. We'll put that on the inside. 270 degrees. If you remember, 90 degrees was pi halves. .180 was pi, and this is 3 pi halves. So we talked about that, so let's put this into here. All right, so 90 degrees, skip 3 of them because we're going to put 3 there. 180 degrees, and skip 1 because we'll put 1 there. And then 270 degrees. All right, so 90 was pi halves, 180 was pi, and then 3 pi halves. All right, so now we're going to talk about some more that aren't right on the axes, kind of in between. We do talk about halfway for here, and here, and there. All right, so if we do another 30 degrees from 180, or from 90, that's 120. And then halfway would be 45 plus 90, which is 135. And then 60 plus 90, we're moving up 60, is 150 degrees. All right, so 90 plus 30, 90 plus 45, 90 plus 60. All right, so let's put that into radians. 120 over 180 reduces to 2/3. 135 over 80 reduces to 3 pi 4ths, which makes sense because it's 3/4 of the way to pi. And then 150 over 180 reduces to 5 pi 6. So 2/3 pi, whoops, 2 pi 3rds, let's put it like this. 3 pi 4ths and 5 pi 6. The only other one we really talk about a lot is the halfway distance here. All right, which halfway between 180 and 270 would be 180 plus 45, which is 225 degrees. And so that's pi plus another half 4th. So 5 pi 4. So 225 over 180 reduces to 5/4. So 5 pi 4ths. All right, you might even want to make flashcards for these, but I would have these memorized. Okay, the ones that match up to each other, where they are in the coordinate plane. All right, we will use these a lot. I cannot stress them enough. So, memorize. Okay, so that's part of your classwork, is to study and memorize that. Okay. All right, the final thing we're going to talk about is what is a coterminal angles. So, terminal means the end. Coterminal means we have the same end, but maybe not necessarily the same degree measurement. So what I mean by that, if we talk about, let's say, and I'm gonna draw this real quick. Don't write this down. I'll tell you when to write. So let's say we talk about, I don't know, I travel, oh, here's an easy one. Let's say I travel 180 degrees. So that's 180 degrees, or pi. I can also say, hey, I also traveled negative 180 degrees, or negative pi. Those two things are coterminal. I went into different directions, but I got the same angle. All right, so let's write that down. So coterminal angles, terminal angles, I guess it should be capital C, are angles whose terminal side sides coincide. All right, any angle with a given, any coterminal angle, excuse me, any coterminal angle with a given angle can be found by adding or subtracting multiples of. So here's where this kind of helps with my pet peeve. Sometimes someone says, oh, he did a complete 360. If you do a complete 360, you come back to yourself again. You should say I could do a 180 because then I'm on the opposite side. But if I do a complete 360, I'm back where I started. So multiples of 360 degrees, or 2 pi for radians. All right, so let me show you what I mean by that. So we're going to do 2 examples. One is we're going to find 3 angles that are coterminal with negative 45 degrees. And then 2, find 3 angles, whoops, that are coterminal with 3 pi fourths. All right, so example 1. So let's think about what that looks like. So here is negative 45 degrees. It's here. All right, so negative 45 degrees. We already talked about that guy. All right, so negative 45 degrees. If I add 360 to it, so if I go around again, I get 315. So if you think about it, here's 315. So 315 go like that. All right. I could go around another. I could also subtract 360 degrees from that. So I could do negative 45 degrees minus 360, which would be negative 405 degrees. So that would be like going like this. All right, negative and then back around to here. That's negative 405 degrees. All right, so I could add 360, subtract 360. I can add a multiple of 360. So I can do negative 45 degrees plus 2 times 360. And that would be 675 degrees. Let me show you what that would look like. So I would go 360, another 360 to there. All right, so multiples of 360. That's pretty cool. All right, so coterminal, you end up at the same place, but you go like another 360 degrees, or you lessen by 360 degrees. All right, so find three angles that are coterminal with 3 pi fourths. And I just realized I can't move the screen up. So I'm just going to have to work on the side here. So 3 pi fourths, you remember we just talked about that, would be halfway in between there. So that's what 3 pi fourths looks like. All right, so I could do 3 pi fourths plus I could go back, I'll back around again. I could do 3 pi fourths and then go backwards another 360. All right, so let's see what those would be. So let's see. I need a common denominator, so 3 fourths plus, this would be over 1. I need to multiply 4, so 8 fourths, which would be 11 fourths with my pi. I could do 3 pi fourths minus 8 fourths. 3 minus 8 is negative 5 fourths. Okay, so again, 3 pi fourths and then I go over another 360. Or 3 pi fourths and I go the other way, 360. Or I could go twice around. So I could do 3 pi fourths plus 2 times 2 pi. Alright, so that would be the same as 3 fourths plus 4, common denominator, 3 fourths plus 16 fourths, which would be 19 pi over 4. So that's how you find coterminal angles. So, you've learned a lot of new stuff in this video. Putting angles on the coordinate plane and radians. And I gave you some stuff to memorize. So I gave you a lot. But I know you can do it. Again, if you have questions, just let me know.